Okay, so here we're going to prove this if and only if statement, which means that we got to prove it in both directions. So I'm going to write it in one direction, prove it in that direction, and then I'm going to write it in the other direction, prove it in that direction. So let's write a proof. So if I want to prove it, right, I got to prove it in both directions. So basically I got to say if AC is perpendicular to L, then AC is the shortest distance from A to L, or you could even say AC is the shortest segment from A to line L. Now, what does that look like? Let's draw a picture of what this looks like and what I have in this situation. So I have some point A over here, and basically it's telling me that AC, this segment, is perpendicular to L. So I have, this is line L right here, and I'm given that AC, this segment AC, is perpendicular. If that's the case, right, I want to show this. I want to guarantee that AC is the shortest segment, right? I want to conclude this in this case. I'm given that AC is perpendicular to L. I want to make an argument to guarantee that AC is the shortest segment from A to L. And how do I do that? I say let AB be any, and the key thing is that it's any other segment from A to L. And you draw in that AB to make it clear. So this is AB, and again, this is any other segment from A to L. Then you have constructed a triangle. You have that this is a right angle as well. You have that triangle ACB is a right triangle with AB as AB as a hypotenuse. And we know, and we proved this, that since hypotenuse is longest side in a right triangle, we have that the distance from A to B is greater than the distance from A to C. And again, AB was any segment. Since AB was any segment from A to L, from A to L, we know that AC is shortest. And you're done in this direction. Now let's state the other direction. The other direction states that you have, it's a little bit more complicated. So the other direction, so we're done in one direction. The other direction is if AC is the shortest segment, or AC is the shortest distance. It depends on how, I wrote it as distance here, but it doesn't matter. AC is, let's say the shortest distance is, AC is shortest distance from A to L, then you can guarantee that AC is going to be perpendicular to L. The segment AC will be perpendicular to L. So proving this direction, right, we got to do a proof by contradiction. So we got to say assume AC not perpendicular to L. So what I have here is that I have, I'm guaranteed that AC is the shortest distance from A to L. and I assume the opposite of the conclusion. So this is the opposite of the conclusion. So assume, right? Assume that AC is not perpendicular to L. What this means is that there must exist some other segment that is perpendicular to L from A. Then there must exist some, AB perpendicular to L. And that looks like this. So you have something like this in this case. You have this is A, and then this is C. And you know that this is the shortest distance by what's given. It says AC is the shortest distance from A to L. And if we assume that this line AC, or this segment AC, is not perpendicular to L, here's L, then there must exist some other segment AB that is perpendicular. And so I'm assuming, right, that AC is not perpendicular to L. Then there must exist some AB that is perpendicular to L. And then that means that triangle ABC is a right triangle with AC as the hypotenuse. And we know the hypotenuse is the longest side, since hypotenuse is longest side. We have the following inequality. We have that AC, the distance from A to C, must be greater than the distance from A to B. But this, and I'm going to write it up here, but this is a contradiction. So this down here is a contradiction. This is a contradiction. And you could write a contradiction with the two arrows facing one another. That means contradiction. And you want a contradiction when you assume something that you want to show being false. So contradiction. This is a contradiction because we know that AC is the shortest distance from A to L. So there's no way that AC, the distance between A and C, is greater than the distance from A to B, because since AC is shortest by what's given. Okay, so that's your contradiction. Therefore, the assumption is false. Is false, and AC is perpendicular to L. And this is the end of your proof right here. Now you're done. You proved it in both directions. You got to prove both directions. Proving in one direction is only half the theorem. The full theorem is an if and only if. This whole thing. Okay, I proved it in one direction, and then I proved it in the other direction.